Good afternoon, Mayfield. It is Thursday, March 20th, and this is my weekly homework video for my pre-algebra students. Not very long. I made it pretty short, and I actually designed it so you could do it before the quiz that was earlier this week, but if you spread it out over the week, that's fine as well. Also, congrats. Those quizzes on systems were amazing. The shoebox today. Woo! Look at this. I feel so popular. Problem one, please. Number one, please. Uh-oh. One, please. I'm loving the pleases. One, please. Woo! I sense a trend. Number one, please. The last one, please. Oh, a little outlier. And number one. And the only reason it doesn't say please is because a student is out sick today. And Canvas messaged me their request, so I put this in there for them. So first of all, thank you for all the pleases, everybody. I appreciate you. Yeah, we can look at number one, and, I feel bad for this one little person. So let me start number three, and then we'll look at number one, okay? This is an example of solving systems. You could always graph it, but it's probably easier if we look at substitution. So y is 3/4 x, which means I could rewrite the second equation to be 5/2 x plus 2 times, instead of y, I'm going to substitute 3/4 x equals 5. And then for here, you're going to apply what you know about fractions, about integers, about balancing equations to solve for x. And then once you do, you'll take that value and you'll substitute it into the first equation to then get your y value. And then your final answer will be an ordered pair. That was a little bonus help. Okay, so my number one pleases. So yeah, number one actually is a lot of fun because everybody could have a different answer and you could still potentially be right. Given the lines shown here, what are two possible equations for this system? So what do I notice about this system? I notice these lines are parallel, which means there's no solution because there's never going to be a point where those lines intersect. Okay, what else do I notice about them? Well, I notice here I have a positive y-intercept, and here I have a negative y-intercept. And I notice that this y-intercept is pretty close to the origin, and this one farther away. So I'm thinking for my first one, I'm going to have y equals, not going to worry about my slope yet, I'm going to say plus 1 for my y-intercept, a little bit above the origin. So down here, I don't know, I'm thinking maybe like -7, right? If this is 1, it's reasonable. Maybe -5, -7. All right, if they're parallel, they're never going to intersect, which means their slope is the same. So whatever you put in for your slope, make sure it's the same for both equations. And your slope definitely has to be positive. Definitely positive. And I'm looking at this. This is not a very steep slope. So I might even make this a little bit more fun and say, you know what, I'm going to make it, a positive 1/3 slope. Maybe each time I'm going up 1/3, up 1/3. That's reasonable. Whatever slope I pick that I think is a reasonable positive slope, I got to use the same one down here, because if two lines are parallel, it means they have the same slope but a different y-intercept. I know they're positive because as I move across the axis, as x increases, y is also increasing. And I picked a pretty small slope because that steepness is not that far away from a 0 slope. So like a slope of 5x, probably I wouldn't give you credit. That's not reasonable based on your interpretation of this system. Now, do you have to have my answers? No. Does your answer have to be reasonable based on the graph, including those key points I just spoke about? Definitely. All right, I will see you tomorrow. Thank you again for all your hard work. I appreciate you. I enjoy teaching you. You're making year 30 one of my best years yet. I appreciate you. Thank you. Bye, everybody. Have a great day.